Convolution, if you remember only one idea from this entire course, make it this one. Everything else is built on top of it. Let's go slowly. We start with a small grid of numbers called a kernel. Here it is just 3 pixels by 3 pixels, a tiny window of 9 numbers. We place that kernel over the top left corner of the image. Now at this position we do 2 things. First, we multiply each kernel number by the pixel sitting underneath it. Then we add up all 9 of those products into a single number. That one number is the output for this spot. Then we slide the kernel one step to the right and do it all again. Multiply, sum, write one number. Watch it march across the image, left to right, top to bottom, covering every position. When it finishes, we have a brand new grid of numbers. We call it a feature map. Now here is the beautiful part, the part that changes everything. The 9 numbers inside the kernel decide what it detects. Fill the kernel one way and it lights up on vertical lines. Fill it another way and it responds to horizontal lines, another and it finds a corner or a spot of a certain color. The exact same sliding operation with different numbers inside becomes a completely different detector. For 30 years, human engineers chose those numbers carefully by hand. And the entire deep learning revolution, the whole thing, comes down to one move. Stop choosing the numbers ourselves, let the machine learn them. Hold on to that thought, we will come back to it. Let's really drive home why convolution is so powerful by trying a few kernels side by side. On the left is our source image. Now watch what different kernels do to it. The first kernel is all ones. It just averages each neighborhood and the result is a smooth, blurred image, good for killing noise. The second kernel has a big positive number in the center and negative numbers around it. It boosts the middle pixel relative to its neighbors, and the result is a sharpened image, edges pop. The third kernel is the difference kernel. It subtracts the neighbors from the center. In a flat region, that cancels to 0 and comes out dark, but at an edge it fires and we get a clean outline. Look at what just happened here, because it is the whole idea in one picture. The operation never changed. It was the same slide, the same multiply, the same sum every time. The only thing that changed was the 9 numbers inside the little window. Blur, sharpen, edges, 3 completely different results from one operation. So imagine having not 3 kernels but hundreds of them, and instead of choosing their numbers yourself, you let the network discover exactly the kernels it needs. That is a convolutional neural network, and that is where we are heading.